In this video, we're going to be discussing data. The first thing we need to ask ourselves is, what is data? Well, our types of data can be split into two main categories: qualitative and quantitative. Qualitative are things like colors, anything that is non-numerical. Quantitative is numerical data, and that can be split up into two subsections: discrete and continuous data. And it is the discrete and continuous data we're going to discuss. The first category we're going to discuss is discrete numerical data. Well, discrete numerical data involves data points that are distinct and separate from each other. There is a definite gap separating one data point from the next. Discrete data usually, but not always, consists of whole numbers and is often collected by some form of counting. So some examples are the number of goals scored in a match. Well, they could be 1, 3, 0, 1, 2, 0, 2, etc. The number of children per family: 2, 3, 0, 4. The number of products sold each day: 437, 386, 401. In each of these cases, there are no in-between values. We cannot have, for example, 2.5 goals in a football match. We can't have 1.2 people in a family. This doesn't mean that discrete data always consists of whole numbers. Shoe sizes, an example of discrete data, are often separated by half sizes. For example, you could have an 8, an 8.5, a 9, a 9.5. Even still, there is a definite gap between the sizes. A shoe won't ever come in the size 8.145. Continuous numerical data. Continuous numerical data involves data points that can occur anywhere along a continuum or number line. Any value is possible within a range of values. Continuous data usually consists of decimal numbers and is often collected using some form of measurement. Some examples of continuous data are height of a tree in a forest, so that could be 12.359 meters, 14.951 meters, 11.032 meters. Time taken to run a 10-kilometer race: 55.34, 58.03, 57.25, etc. Daily temperature: 24.4, 23.0, 21.6, 19.7. In practice, continuous data will always be subject to the accuracy of the measuring device being used. You could argue that height, or even time taken to run a 10-kilometer race, could be given as discrete data, because let's take the race. It's going to be rounded usually to the nearest hundredth of a second. The height of a tree is always going to be usually given to 2 decimal places, but you would never get a height of a tree at exactly 12 meters. It would be between a range that has been rounded. So I would put height and time taken to run a race in continuous data. So in summary, the difference between discrete and continuous data: discrete data can take only certain values. It is usually countable, and some examples are shoe sizes, the age of students in years, number of students in a class, number of goals scored in a football match, number of pages in a book, time to run a marathon, if it has been rounded. So the time to run in a marathon could be in both. Examples of continuous data. They can take any value and it is usually measured. Height, weight, length of someone's hair, room temperature, length of a person's index finger, water temperature.